So next speaker, Gergely Daroczi, right?
Yeah.
Is it correct? And topic is vendor-independent cloud computing hardware information and benchmarks.
Merci, and bonjour. Je suis Gergely ou Grégoire Daroczi de Spercourse, and c'est un grand plaisir d'être ici. Je ne peux pas parler bien français, so I will need to switch to English. And as I said, or as I tried to say, it's a great pleasure to be here. This talk will focus on how to utilize cloud resources in the most cost-efficient way. And when I say cost-efficient, that also means like energy-efficient and in the most performant way as well. So to give you some background, why would you want to do that? I've been working as a data scientist, managing data science teams and infrastructure for the past decade. And there are many different types of jobs that we are running. Sometimes it's just SQL, like ETL task and so on, which is super lightweight on the client or server side. Everything is running within the database. But in most cases, you are running an R, Python, or some other kind of scripts or programs, which might be also lightweight, like training a linear model can be super simple, doesn't need a lot of compute. But in other cases, like you're training a hierarchical model, which requires hundreds of gigs of RAM, or training GBMs, or you might need GPUs for NLP stuff or some other things, there are diverse need for compute. So my problem when we started Spercourse was scaling the data science or ML model training infrastructure. And to give you an overview on the prototype that we have built at an edtech company previously, you can see here that we collected data on a bunch of Docker containers every second or every few seconds. You can see the CPU usage and the memory usage. So for this guy, we have seen that it cannot scale to multiple CPUs. It's tied to a single core. It's using around 200 gigs of RAM, so maybe training some hierarchical models. And there were some other patterns as well. So we had around 4,000 Docker containers like this running every single day with diverse compute needs. And of course, we were looking at some of the existing solutions, like we used ECS, scaling up clusters, starting Docker containers there. We were happy for AWS Batch, and we gave it a try. Of course, Kubernetes is kind of the industry standard. But unfortunately, it's not the best fit when it comes to training ML models and doing data science, because bean packing is ideal for traditional applications which are running in 24/7. You can place multiple containers on the same server. For data science, when you need 200 gigs of RAM with a single CPU core, for another job you need 8 GPUs. Putting on the same server doesn't make sense because you will waste a lot of money. Like at the edtech company, we spend around 5,000 USD monthly. We reuse that to 1,500, so around 65% cost savings by getting rid of bin packing. This is how it worked. It was a couple hundred lines of Python script, spinning up AWS servers, deploying the Docker images, starting the Docker containers, monitoring end-to-end, tracking compute usage of those Docker containers, and also taking care of the capacity issues. Like, I'm not sure how familiar you are with the different vendors, but first you have to have a battle with the vendor for quotas so that you can have like 100 GPUs. That's not easy to get there with a new account. Then you have the capacity issues. Like, you have the quotas, but you cannot start the machines because there's no capacity. So you try looking for the resource in another region and so on. That's happening in here. And once the job finished, we also track the exit codes, collect stats, we are streaming the logs and taking care of a bunch of other things within a couple hundred lines of Python code. So this turned out to be useful not only for data science, but it turned out that within the same company, others needed bad jobs as well, like traditional CI/CD stuff, compiling software, testing. ETL team also had some Python scripts, so it turned out that this is useful for others. We decided to open source. This was called CloudPerf, been out there for like 7 years, but it's tied to AWS and had some other limitations. We were working on this as part of our edtech company job, so we needed to focus on features which the company needed. That's why we applied for funding at NGI Search last year. We got the funding and we managed to work on this part-time / full-time and take this open source tool where it needs to be. And this is how SpareCourse, which is the next generation of CloudPerf, was born. To keep it short, it's a collection of open source software, database schemas, and documentation. And whenever I say open source, everyone is asking how many stars you have on GitHub. And we do not have many. This is because I think folks do not usually want to run ETL stuff on their own. We are also starting every single server that we encounter, run benchmarks on those, and we even start servers which cost like more than 400 euros per hour. So I'm pretty sure no one wants to waste a lot of money just to run the benchmarks. So instead of letting folks can still run this if they wish, but we do that for them. We manage a database, we keep it updated every 5 minutes. When it comes to the pricing, we keep track of the performance and so on. We create web components, APIs, SDKs, so that you have programmatic access and so on. So to give you some high-level stats, this is a bit outdated. We have integrated 5 vendors now and constantly adding new ones. Of course, we cover the hyperscalers, AWS, GCP, Azure, integrated Hetzner, UpCloud, and Scaleway, and a few others coming up as well. This covers more than 2,000 server types. And when we are just focusing on the current price of a server, this is almost 300,000 data points for the time being, not including the historical records, which is well over 20 million records. We are updating this every 5 minutes, and we collect a lot of stats on the machines after starting, so we have close to 1 million performance cores on the performance for different workloads. The easiest way to get access to this data is looking at our homepage. You have some filters on the left. You can see all the servers in a table. You can toggle columns and make that fine-tuned to your needs. Once you click on a server, you get detailed information, which is much more than what the vendor APIs cover. So we, for example, take care of the level 1, 2, 3 cache amounts of the CPUs and all other tiny details, and I will show that to you. Of course, we have prices. Here you can see a few examples of the benchmarks we run. For example, memory bandwidth, or looking at OpenSSL speed, running some block ciphers and hash functions with various block sizes, or Geekbench or the Passmark results are recorded for all the servers so that you can compare an Azure machine to GCP machine as apples to apples, so you know what to expect from those. We also make these comparisons as tables and some charts, like here you can see the Geekbench results for single core and multi-core performance for a couple of servers, also memory bandwidth that I showed previously. For programmatic access, we have APIs and SDKs, and just this is the Python one. Here you can see some metadata on the server, and let me scroll down here just to show, for example, when it comes to the GPU, we even record the firmware version, which might be important for some ML use cases. So it's a lot more information compared to what's available on the net. SpareCourse is, as I mentioned previously, a collection of different components. The crawler is the ETL, and let me do a quick overview on this. So this is an ETL framework with database schemas. We take care of a bunch of things, but to keep it short, it's an integration around vendor APIs so that we can have a list of SKUs of servers, regions, zones, storage types, and the prices. And then we run the benchmarks and integrate that as well. It also serves as a dependency of all the other components. And honestly, we thought that this will be a super easy task, like ETL, right? It's boring, you do that in a couple of days and then you forget it. Unfortunately, it's not, and there are some technical reasons. Super happy to share more if you're interested, but taking care of the overlapping compound primary keys problems and supporting historical records in the means of the SCD table, sharing primary keys with the normal tables, taking care of database migrations, and so on. It's a little bit of problem. But the biggest problem was that data is very confusing, at least how the vendors share that. And first, I just wanted to take a quick look, like how much data is available on the internet right now. And there's ChatGPT, so let's quickly check how much storage this server has at AWS. And this guy searched 6 sites and found that it has 12 HDDs, but doing the multiplication was just too difficult. So there's some hope that SpareCores is still useful because ChatGPT cannot solve for that problem. But to show you some real world problems when it comes to data quality and even the availability, like if you're interested, if a server has an SSD, it's printed on the web page on the vendor's site, but the API doesn't provide this information in a structured way, but you have to parse that from the server description, or it's not even in the server description. And to give you an even simpler example, if you look at this guy, EU West 1, that's probably familiar if you have used AWS before, but this region is called actually Europe Ireland, which sometimes is referred to as EU Ireland, even in the AWS console, and they make you to select that, so it's not interchangeable. So we standardized that part as well and added some extra information like the exact locations of the data centers, the energy source if they are using green energy, and so on. And some further examples of how messy this ETL task is. Some vendors provide the price of a server as an hourly price. Very simple. Some others are saying that you have to compute the server price by multiplying the CPU price for a server family, do the math for the memory as well, and add it up. But the server family is not provided in a structured way. You have to parse that from the server description, and sometimes you have to do mapping, like C2 server family is referred to as compute optimized, and a bunch of other crazy things need to be taken care of. The good news is that we have done that. We maintain the database, so you can just download the SQLite file and you have everything in a clean format. The easiest way to use this is using our Python package, which is using a SQLite file in the background, which is updated by public and free GitHub actions. So everything is running in the public. We have almost 1,000 releases by now. This is available by open and free licenses. And I have already shared some stats, so I will skip that, but I want to mention that this small Python package will continuously update the SQLite database in the background thread. Regarding the other components, and I will try to keep it short, I know we have some issues with timing. So the inspector is actually starting or running different hardware inspection tools on the machines. Here you can see a few examples. We are continuously adding new ones, and also some benchmarking workloads. And we have added many, many more since then, like benchmarking Redis, serving static websites, working on LLM inference speed benchmarks using both CPUs and GPUs. So there are a bunch of different workloads, and hopefully you can find the one that's related to your work. To run this, we are using GitHub Actions again. We have like almost 100,000 runs now. So within these GitHub Actions, we are spinning up the machines in the cloud, start the Docker container, collect the data, and the data is committed to this Git repo. So the raw output of the benchmarks is available in the Git repo and in a structured way in our SQLite database as well. If you wish to run the inspector on your own machine, like your laptop, your server, supercomputer, or whatever, to serve as a benchmark, as a baseline for the benchmarks, you can do that. We have this Docker image published. You can very easily run it on your machine. Regarding the runner, which is actually starting the machines, we are using Pulumi in the background, which is a very nice open source tool to define infrastructure as a code. Unlike Terraform, it's not a unique language, so you can write Python or TypeScript or whatever. We are using that to spin up the servers in all the clouds. And just some fun facts. I mentioned quota and capacity issues previously. So at some vendor, we asked for more resources so that we can also benchmark some GPU-based machines. And this is the interface how you ask for a quota increase. Finally, we encountered quota update request quota, which is quite interesting. So anyway, good luck with the new accounts. Hopefully SpareCores can help you mitigate some of those problems. The Keeper, this is a REST API It has redock and Swagger docks if you're interested. It has a thin layer of OpenAI integration so that you can put in plain English terms for what kind of server you are looking for, and then it will provide you a mapping of filters and give you the matching servers. Of course, this is it's rather for fun and not for production use. For production, we have the APIs. I've shared about the web component previously. Please take a look. We have a fun slot machine where you can just enter the number of CPUs and memory you need, click spin, and this will interactively show you the top 3 cheapest resources across multiple clouds. Of course, again, this is rather for fun. I would rather recommend using our SDKs or APIs, but as a starting point, this might be useful. Regarding the future, we have plans to add further renders, integrate multiple new benchmarks, especially when it comes to GPUs, which is like a whole new world and there's a lot of complexity. We are trying to be active in online and offline tech communities as well, like in Reddit. We were featured on the Programmatic Engineer a couple of weeks ago. It was great to be exposed to 750,000 subscribers and received some good feedback from there. We are working on a software as a service solution built on the top of this. So everything that I mentioned will remain open source and free forever, but we would like to provide a service so that you do not even need to engage with the vendors directly. We can take care of everything, including end-to-end management of the Docker containers, but that's to come up in the next year. Regarding the team, of course, I'm not working on this on my own. I'm in a good company, as you can see the avatars of the other 2 guys. I'm mostly focusing on the data parts and managing the projects. Attila is taking care of all the cloud stuff, and Balu is taking care of the front end. And I would like to thank OW2 and NGI Search for their ongoing support. Honestly, SpareCores was born because NGI Search was there. We applied for a grant, we received that grant, and that's how we managed to turn this weekend project into an actual open source solution, which is useful for many. So thank you very much for that. And I know that time is up, so I will stop in a bit, but before we have actually a booth at C20, so please come by. I have some hex stickers, some flyers, and I'm very happy to share more if there are questions. Also, if you cannot do that, please check us out. I'm in the homepage, we are on social media, and I will stop right now. Thank you very much again for the opportunity.
Thank you very much. Des questions?
You can find me at the booth, so.
Dans tous les cas, il est au C20. Merci.
Merci beaucoup.
Thank you.